In this lesson, we will learn how to perform descriptive analytics for univariate qualitative data. So recall that qualitative data can be either on nominal scale or ordinal scale. Nominal scale data cannot be ordered meaningfully. Some examples: city, state, zip code, gender, race, color, etc. Now, ordering data alphabetically may sound meaningful, but remember that the alphabet itself is an arbitrary ordering of letters created by man for convenience. There's nothing natural about the sequence of letters in an alphabet. Ordinal scale data, on the other hand, can be ordered meaningfully. For example, grade A, B, C, D, F. Rank in college, freshman, sophomore, junior, senior. Military rank, customer satisfaction rating, etc. So let's say we have a single column of ungrouped qualitative data like this. Let's have another example. So we have two examples of single column of ungrouped qualitative data. In the first example, the qualitative variable is a state and it's on nominal scale. So we have 25 orders. The first order is from Florida, third from Georgia, and so on. In the second example, the qualitative variable is grade, which is on ordinal scale. So student 1 received an A, student 3 received a D, and so on. So each of these columns, the state column and the grade column, has a different story. So in the first example, just by a visual examination, we can see that there's more orders from Florida than from any other state, but we cannot be more specific as to what percentage of orders are from Florida and what percentage from Georgia, etc. In the second example, it's kind of hard to make any obvious observations. So in such small examples, it's hard to tell a story by a visual examination. So in this lesson, we will learn how to make sense of univariate qualitative data systematically. Now, most of the descriptive analytics is common to nominal and ordinal scale qualitative variables. But with ordinal scale variables, we can do some more things that we cannot do with nominal, and we'll discuss those a little bit later. Descriptive analytics for univariate qualitative data. Summary measures. Since there are no numbers involved, we cannot compute any mean or median or quartiles or percentiles or standard deviations, etc. The only summary measure that we can compute is the mode, because mode depends on the frequency and frequency can be computed for qualitative data. Can we do any charts or graphs for ungrouped qualitative data? No, there's no possible charts for ungrouped qualitative data because there are no numbers. Charting requires some numbers. The only way to have some numbers for qualitative data is to compute the frequencies by converting ungrouped data to grouped data. So we convert ungrouped data to grouped data, then do the following. For both ordinal and nominal, we create a frequency distribution table. We have the frequency column and the relative frequency column. So we are capturing the frequency of each unique qualitative value. We can create the column chart, but remember, the shape of the chart is meaningless for nominal, meaningful for ordinal. We can create a bar chart of the frequencies, again remembering that the shape of the chart is meaningless for nominal, but meaningful for ordinal. And we can create a pie chart. Now, if the data is ordinal in nature, then in addition to frequency and relative frequency, we can also have cumulative frequency and cumulative relative frequency. Another thing we can do is assign numerical values to the various qualitative values, then treat the data like discrete quantitative data. However, when we assign numerical values to qualitative data and perform analytics like quantitative data, we need to be cautious when interpreting the summary measures and the charts. We will talk about this towards the end of this lesson. So unless we convert ungrouped qualitative data into group data, we cannot perform any descriptive analytics. So let's group this. Once we group the data, what do we get? We get a frequency table. So here we get a distribution of number of orders by state. Now in this example, it's just by chance that my states are alphabetical in nature. They don't have to be. And these are not in any particular order. They're neither ascending nor descending. We can also group the grade column and create a frequency table of all the grades. Now here, we can technically say that Florida is the mode value because it has the highest frequency. However, the term mode is usually used with quantitative variables, but you can use the word mode here also. Similarly, we can say that the grade of B is the mode grade because it has the highest frequency of 9. But again, usually we do not use the measure of mode in the context of qualitative variables. Once we have the frequency column, we can extend it to get relative frequency and cumulative frequencies for both the examples. However, we have to be careful. In this example, since the state is on nominal scale, cumulative frequencies and cumulative relative frequencies are not valid. We should not have done this. Why are they not valid? Because the ordering of the 4 states is arbitrary. So this ordering is arbitrary. One order is just as good as another. But if we change the order, the cumulative frequencies change. Therefore, no particular set of cumulative frequencies is meaningful. We cannot make any meaningful statements from the cumulative frequency columns. For example, we cannot say that 88% of all the orders are from North Carolina or above, because these are the above states, but the above states could be below North Carolina in another arbitrary ordering. Whereas here, since grade is on ordinal scale, cumulative frequencies are valid. Why are they valid? Because the ordering of the 5 grades is meaningful. We cannot order them in any different way. Now we can order them as FDCBA, which is fine. These numbers will be reversed, but they will still remain meaningful. So for example, here we can say 80% of all students received a grade of C or above. If we reverse this ordering, we will make a statement appropriately. We can say so many percent students received a grade of C or below. So we get rid of the cumulative frequency columns. We just have the frequency and relative frequency here, but we have the entire extended frequency table for grade. Using the frequency values, we can create a column chart. Using the frequency values, we can create a grade distribution chart, which is a column chart. Note that here we cannot interpret the shape of this distribution. So this particular shape, skewed to the right, is just by chance. If I had put Florida and Georgia in the middle, it would not look skewed to the left or skewed to the right. Whereas here, we can interpret this shape. We can say the shape is skewed to the right. Because the ordering is meaningful, the shape is meaningful. Instead of creating a column chart using the frequency values, we can create a column chart using the relative frequency values. Relative frequency chart allows for better storytelling. Now we can say that, oh, almost 50% of all orders come from Florida. We cannot have made this a statement using the column chart on the previous slide because we were only looking at absolute values, not relative values. Similarly here we can say, oh, almost 35% of students received a B. So relative frequency chart allows better storytelling, and since the ordering is meaningful, the shape here is meaningful. Because the ordering is not meaningful, the shape here is not meaningful. Instead of creating column charts, we could also create bar charts. They have the same amount of information as column charts. Some people just like this one better than others. Normally, we create bar charts when the number of unique values is large. For small number of unique values, column charts are preferred. For large number of unique values, bar charts are preferred. But there is no hard and fast rule. Instead of column charts and bar charts, we could also create pie charts. Now here we could use either the frequency column or the relative frequency column. We will get the same pie chart because if we use a frequency column, Excel will automatically compute the relative frequencies anyways. So we will get exactly the same chart whichever column we use as input. Now let's talk about what are some of the things we can do with ordinal qualitative variables that we cannot do with nominal. So sometimes it helps to assign numerical values to ordinal qualitative variable values and then treat the variable as discrete quantitative variable and perform all the descriptive statistics on those numeric values as one would do for a discrete quantitative variable. However, when we do this, we should be cautious. What's the caution? Well, the numeric values are somewhat arbitrary and may not have the same meaning as pure numeric value. For example, we can assign values of 4, 3, 2, 1, 0 to grades of A, B, C, D, and F respectively. Every college does this. Every school does this. But remember that these assigned numeric values do not have the same relative values as pure integers. So, 2 is 1 greater than 1, 3 is 1 greater than 2, 4 is 1 greater than 3. So the interval between 4 and 3, 3 and 2, 2 and 1 is the same. But is the interval between A and B, B and C, C and D the same? Not necessarily. So we cannot say that a grade of A is twice as good as a grade of C because 4 is twice of 2. We cannot say that. Similarly, we cannot say that a grade of B is 25% worse than a grade of A because 3 is only 75% of 4. So assigning numeric values to qualitative values just makes it convenient to compute some numeric summary measures. But we have to be very careful when we want to interpret those summary measures. So here we are converting grade to grade point and then using the grade point column, treating it as univariate, discrete, quantitative column, we can compute all these summary measures. And we can talk about them, but we should be careful when comparing them. Once we convert it to group data, we can create cumulative frequency, relative frequency, cumulative relative frequencies, and then we can create a column chart using the frequency column. We can create a column chart using the relative frequency column. We can create a pie chart. The only difference is instead of A, B, C, D, F, we are seeing 0, 1, 2, 3, 4. In this example, the order is actually reversed. It is F, D, C, B, A. In the previous charts, it was A, B, C, D, F, which is fine as long as we have some order. Because the ordering of grades is reversed, here the distribution is skewed to the left. In the previous example, because we had put A, B, C, D, F, the distribution appeared skewed to the right. So again, when we do the conversion, we have to be careful when interpreting the descriptive analytics. So this concludes our lesson on descriptive analytics for univariate qualitative data.